Hello dear friends, we are studying nonlinear partial differential equation of order 1 and different forms we have to study. Last time we have studied standard form 1 and we have obtained a method to solve that type of equations where complete integral and general integral exist. Singular integral does not exist for standard form 1. Today we shall study the second standard form 2. I have written some problems here. First we will see what is the form and what is how to obtain the solution of that form. Then we will solve these problems. Now this equation, this PDE is of the form, or this PDE is of the type Z is equal to ax plus by plus it is not a but p and q. So it is partial differential equation. Z is equal to p into x plus q into y plus a function of p and q. So this type of partial differential equation, p is a partial derivative of z with respect to x, q is that of with respect to y, and this is function of p and q. So this PDE is called standard form 2nd. Now the complete integral of this PDE is given by its complete integral is z is equal to a into x plus b into y plus function of a and b. Now we suppose this as 1. Now the justification for this, why this is a complete integral of the standard form 2nd, this form, so that we shall easily see justification for complete integral. We have from 1, differentiate 1 with respect to x first, and that is dou z by dou x, partial derivative of z with respect to x. We denote that by p, which is partial derivative of z with respect to x, and we see when we are differentiating with respect to x, the derivative of x is 1, it is constant, and remaining are to be treated as constant. That is, a, b are constant, and y is to be considered also constant when we differentiate partially with respect to x. So therefore these derivatives is 0. Similarly, next, that is q is partial derivative of z with respect to y, and partial derivative of z with respect to y will be only b. This we have seen earlier also. A and b are constants, arbitrary constants, and thus what we have is p is equal to a or q is equal to b, or in turn a is equal to p and b is equal to q, and we put these values in 1. So putting these in 1 again, so putting a is equal to p and b is equal to q in 1, so we get, see this 1 becomes z is equal to, and a is p, so it is p into x, plus b is q, it is q into y, and plus function of p, which is the PDE of form 2. So which is the given PDE, and thus therefore this satisfies this PDE, and it has number of arbitrary constants too as the number of independent variables. So therefore this is complete integral. Therefore 1 is the complete integral of this standard form 2nd, and this is about the justification of complete solution or complete integral. So we should remember both of this standard form 2 is this one and its complete integral is this one. Now we will write about the remaining integral, that is general integral. First we shall consider. And to obtain general integral, what we have to consider is b as a function of a. Let b is equal to phi of a, where phi is arbitrary function. this is the same procedure that we are following as we have followed for obtaining general integral in form 1. And let b is phi of a, but here one thing is that this b is to be considered as arbitrary function of a. And in our first case standard form we have obtained b by the relation f of a function of a and b is equal to 0. So that is the difference here. So b is a function of a, phi is arbitrary function. Then put this value of b in 1. So then 1 implies, so from 1 what we should get is z is, so this is z is equal to a into x plus b we are considering phi of a into y plus, and this is function of a and phi of b. And we suppose this as our next equation as second. Now further we differentiate second. Differentiate to partially with respect to a. And what we shall get is partial derivative of z with respect to a is 0. Partial derivative of a into x is with respect to a, that is x, plus this is pi dash of a into y. Y is to be treated as constant, and plus the derivative of this we should write, that is f dash of a, and this is not phi of b but phi of a, and that is plus function of, that is that can be written as dou f by dou a. So this is the derivative for second. And we can suppose this as our third equation. Only eliminate a between second and third, because this is arbitrary, we don't know what is the exact nature of this function. So only the procedure we should write for general integral, so for solving these PDEs, and we eliminate a between 2 and 3 to get the general integral. Eliminate a from 2 and 3. To get the general integral. So this gives the general integral. Now next is singular integral. So this is to be obtained from the complete integral again. See, this is the complete integral. We differentiate the complete integral 1 partially with respect to a and then b. Differentiate 1 partially. A and b. So what we shall get, again the derivative of z with respect to a, partial derivative of z with respect to a is 0, and this will be x, and this is 0, and this is partial derivative of f. This is a function of a and b, and we have how to differentiate partially with respect to a. So therefore this we should write as dou f by dou a. So this is the partial derivative of 1 with respect to a, and we number this as 4, equation number 4. And what about the second equation? Similarly it will be 0, derivative with respect to b, partial derivative, and this is 0 and this will be y. So y, and similarly it is a partial derivative of f with respect to b, and we number this equation as 5. Now we eliminate a and b between 1, 4 and 5 to get the singular integral. Eliminate a and b from 1, 4 and 5 to get the singular integral. So this is the procedure to solve PDE of standard form second. So it is z is p into x plus q into I plus function of pq. Complete integral is this one. From this complete integral, we have to obtain general integral by considering b is equal to phi of a, and also the singular integral is obtained by 1, differentiating partially with respect to a and b, and then eliminating a and b from these three equations 1, 4 and 5. Now this procedure we will use to solve the problems of this type. Here I have written the problems. We shall solve these one by one. Now consider the first problem. So I shall write the solution from here. Solution of 1. Solution 1. Observe the equation. It is z is equal to px plus q into I plus pq. Z is p into x plus q into I plus p into q. It is of this form. You see, z is equal to p into x plus q into I plus function of p and q. It is here p into q. So it is of the form. It is of standard form. So its complete integral is replacing p and q by a and b. It is simple to remember. How to write the complete integral of this form? Replace p by a, q by b everywhere and in the equation. So its complete integral is we have written justification for this. How it is complete? It becomes complete integral, and that is here z is a into x plus b into I plus a into b. So this integral, first integral, we shall assume as 1. So this is about complete integral. Now we obtain the general integral. So the second part is general integral. So we have written the procedure earlier, how to obtain general integral. For that purpose, we suppose b is equal to function of a, where phi is arbitrary function. And put this value, so 1 becomes. Therefore, from 1, what we get z is a into x plus b, we are considering phi of a into I, and plus a into phi of a. B is phi of a. And we suppose this as second. Now what we have written, differentiate second partially with respect to a. The same procedure we are following that we have written in the method. Now differentiate this partially with respect to a. So what is the left side? That is 0. It is the same. And partial derivative of a into x with respect to a, that is x. And next partial derivative of phi of a into I, that is same. Phi dash of a, function of a, its derivative is pi of a, derivative is phi dash of a, y is constant, and plus. Now here is the change. Here the third term is a into phi of a, and earlier we have written f of a and phi of a. So this will be changed. And what is that derivative is, we have to use the product rule, and that is a into derivative of phi of a, that is phi dash of a, plus derivative of a, that is 1, and pi of a as it is, that is phi. So this will be our equation 3, and only we should state that eliminate a and b from 2 and 3 to get the general integral. So this procedure we have to write only for general integral, because we will not be able to solve this equation unless what is the arbitrary function phi is known. Now we shall obtain singular integral. Now what is the procedure for singular integral? Differentiate 1 complete integral partially with respect to a and b, or to obtain. See, what is the derivative of partial derivative of z with respect to a? This is 0, and that is again x, and this is 0, and this we have written function of a and b, and this is the dou f by dou x. F is here ab. What is the partial derivative of ab with respect to a? That b is constant and derivative of a is 1. So this will be b. And now differentiate this partially with respect to b. So that is again derivative of z to be treated as constant when we differentiate partially with respect to b, 0. And these two are constants, it is 0. And derivative of b with respect to b partial is 1, y is constant, so it is y again. And derivative of a into b partially with respect to b will be a, because a is constant, derivative of b is 1. So these are partial derivatives, should be written carefully. And thus we have obtained 4 and 5. So what we have written, eliminate a and b from 1, 4 and 5. This equation 1, the fourth equation and fifth equation. So we eliminate AB from this to get the singular equation, and actually we have to get here. So eliminate A and B from 1 and 1, 4, 5 means we have to obtain the value of, we can obtain the value of A and B from 4 and 5 and put it in 1. So what is the value of A and B from 4? From 4, what is b? B is equal to negative x. And from 5, a is equal to negative 1. So put this in 1. Putting these in 1, we get. So what we should get is z is equal to a is negative x into x plus b is negative y into y, and plus again a is negative x, b is a is negative y and b is negative x. So this is to be simplified, and you see it is positive xy, and so what is the mistake here is a into x. A is negative y. So this is negative xy, and so what is the b? The b is negative x. Put the value of a and b in 1. Should verify this. And we may see here this is negative xy and this is positive xy cancels, and only this term remains. That is z is equal to negative xy. This is the singular solution. So in this way we have obtained complete integral, then general integral, procedure for obtaining general integral, and singular integral we have obtained. So z is equal to negative xy is the singular integral of the given equation. So this is complete solution for the first problem. Now we shall consider the second problem, that is z is equal to p into x plus q into y, etc. Solution for 2. The equation is z is p into x plus q into y plus c into under root of 1 plus p square plus q square. And this is of the form second. P into x plus q into y, these two terms fixed. Only then it may differ by the third term, function of p and q. C is a constant, and this is function of p and q. So therefore it is of the form standard form 2. So this is of type standard form 2, and its complete integral is by this, you see, z is equal to a into x plus b into y plus function of a and b. That means p and q are to be replaced by a and b. So therefore this becomes c into under root 1. In place of p we have to write a, and in place of q we have to write b. So this is the complete integral of this. So it is easy to write complete integral directly by replacing p, q by a and b respectively. Now we should consider general integral. So here the procedure we will write for general integral. Let b is equal to phi of a, where phi is arbitrary function. Then from 2 what we shall get, you may see that only we have to put the value of b there, and the value of b is phi of a. So that we get z is equal to a into x plus b is phi of a into y plus c into under root 1 plus a square plus phi of a whole square. And this is say third equation. This is our third equation. Now what we shall consider is that we have written here. So differentiate 2 partially with respect to a. So this should be second. This is 1. This is 1 and this is 2. We are numbering the solution only. The original equation we are not numbered. This is complete integral, we give number 1, and for the next it is second equation. So now differentiate 2 partially with respect to a. So we have differentiate this partially with respect to a, and then what we will get is, we will see here. So it is 0 is equal to x plus phi dash a into y, this one. And here this derivative, partial derivative with respect to a is to be written. This is a function, entirely function of a. And by root function, derivative of root of x is 1 over 2 into root x. And therefore this will be c into 1 by 1 over this, and the derivative of the term under radical sign is to be written again at numerator. So I shall write this as, so this will be root 2 into root of 1 plus a square plus this is phi of a whole square that the derivative of root function 1 upon 2 into root. And now the inner function is this one, its derivative is to be written here, and that will be derivative of 1 is 0, derivative of a square is 2a, and derivative of square of phi a is 2 into phi a into derivative of phi a, that is phi dash. So 2 is common, and in bracket it will be a plus derivative of this is 2a, and this is 2 is written outside, phi of a into phi dash of a. So this should be denoted by third equation. This is 3, and 2 can be cancelled, and we eliminate a from 2 and 3, the last two relations, to get the general integral. So that is the way to obtain general integral. Now singular integral we have to write. Differentiate 1 partially with respect to a and b. So what we shall get is derivative of 1, partial derivative of 1 with respect to a, 0 is equal to x, and this is 0, and derivative of a partial derivative of this 1 with respect to a, and that will be plus c as it is, and it is 1 upon 2 under root 1 plus a square plus b square into derivative of inner function, that is only 2a, and this is 2a. So these two can be cancelled out, divided out, and we get this as x plus c into a divided by this. And similarly, so I shall remove these two. You can verify this. And then suppose this as a 4. And similarly, the partial derivative of this with respect to b will be 0, and that is y plus c into, in place of a there will be b, 1 plus under root of 1 plus a square plus b square. And this is our fifth equation. So from this we can write the value of say x square minus y square. So I shall now rub out this. So this gives we will square and add it. Or we can write from this as the value of x or negative x is equal to a into c divided by this root, and negative y is b into c divided by this. So if you square and add, so therefore x square plus y square will be equal to, and this is a square into c square, a square into c square plus c square into b square, and in that c square is common. So I shall write directly c square is common. In bracket it remains a square plus b square divided by square of the denominator is 1 plus a square plus b square. You can check it easily, and this is x square plus y square. From this what we should write is the value of 1 upon or c square minus this. So therefore c square minus x square minus y square, c square minus this, c square minus c square into a square plus b square. Why we are doing these steps? Because we want to eliminate. We want to eliminate a and b from 1, 4 and 5. So equation 1 is earlier we have written direct solution, and this is 1 plus a square plus b square. Now what is the left side? Right side, cross multiply, that will be c square plus c square into a square plus b square, that cancels with this, and divided by the denominator. So only c square at numerator will remain. So you can verify this. This term cancel with this product, and c square remains, c square divided by 1 plus a square plus b square. This is what is a c square minus x square minus y square. And again from this the value of 1 upon 1 plus a square plus b square. This will be, take this term on other side, and it is c square minus x square minus y square divided by c square. So this is the value that we have obtained for this one. And now from using this we shall find out the value of a here. So we have from 4. From 4, this value of a is, say x is minus a into c divided by this value, and therefore what is a? A will be, so you shift this term on this side, that is negative x, and then this is under root, or we can write the value of a as, so you see that will be x into negative x into, or we should write as c into a divided by under root 1 plus a square plus b square. Or from that a is equal to, what will be a? Take these two terms on this side, that is minus x into root of 1 plus a square plus b square divided by c. And one thing is this value root of a square plus b square can be obtained from this relation. So that will be minus x upon c, and we take the reciprocal and then take the root. So we may number this equation as say 4, 5 and we have 6. Or one more step can be done here, take the reciprocal and take the root. So take the reciprocal means this interchanges and then take the root, and therefore that value will be c divided by root of c square minus x square minus y square by 6. We should verify this from 6, taking reciprocal and taking root and putting this value here. We have done, and this c term cancels, and what we get is a is equal to. So therefore A is minus x divided by root of c square minus x square minus y square. Thus we have obtained A. We want to eliminate A and B. So therefore we have obtained the value of A. And by symmetry and similarly, see these two equations. In place of A, here is B, and the expression is symmetric. So therefore similarly we can write what is the value of B. B is negative y divided by under root c square minus x square minus y square. Now we put these values in 1. That is complete solution. Now what is complete solution? What was complete solution for this equation? Second, we are solving second, and the complete solution integral of this equation is z is equal to a into x plus b into y plus c into under root 1 plus a square plus b square, and that we have numbered as 1. Now we write, putting these in 1. Putting these values of a and b in 1, we get, now see the equation 1. It is z is equal to a is this one, into x. So it becomes negative x square divided by x into x, this x into this x, divided by under root of c square minus x square minus y square. And next term is b into y. So but b is again this one, multiply this by y, means it becomes minus y square divided by under root c square minus x square minus y square. And the next term is plus c into the same term, root of 1 plus a square plus b square. But again that value from 6 is root of 1 plus a square plus b square. Now I shall write that value here. That will be root of 1 plus a square plus b square. Take the reciprocal and take the root. So this is c divided by under root of c square minus x square minus y square. And we may assume this as 6. So then put this value here, c into this. So c into this term means c square. It becomes plus c square divided by, the denominator is again the same, c square minus x square minus y square. Now further we may observe that the denominator is the same. What is the numerator? Numerator is minus x square minus y square plus c square. Means again it is c square minus x square minus y square. So the right side is c square minus x square minus y square divided by root of c square minus y x square minus y square. So that is that means root a divided by a divided by root a. So that will be root of the expression. You can verify this, and therefore this is z is equal to, the next step will be z is c, or otherwise we will write c square minus x square minus y square divided by under root of c square minus x square minus y square, or that means z is, so this divided by its root of c square minus x square minus y square. And to eliminate the root, so here using 6 and squaring, what we should get, z square is equal to c square minus x square minus y square, or that is x square plus y square plus z square is equal to c square. So this is the singular solution. Singular solution of given equation, and this completes the solution. Actually what it represents a sphere in 3 dimensions, and thus this gives the solution. For third, you should try yourself. Third problem, try in the similar way that we have solved the earlier problems, first and second. So it is easy, you can solve it. And what is the complete integral for this is z is equal to, complete integral can be written easily by observing this. This is complete integral or CI. Z is equal to a into x plus b into y minus 2 into root a into b. This is complete integral. So general integral is only to write a procedure. Put b is equal to phi of a, differentiate this partially with respect to a, eliminate a between these two equations to get the general integral. And you should write that procedure, general integral. And singular integral is here in this case x into y is equal to 1. So this is the singular integral. You should try this by so this is easy. You differentiate this partially with respect to a, and what that gives is 0 is equal to x and minus etc. You verify this. This is the singular integral. So third example, please try yourself and verify the answer. So this is about the standard form second that we have studied, and how to solve the equations of standard form second to obtain its complete integral, general integral and singular integral. So remaining form, that is the next form is third form, we shall consider in our next lecture. Thank you.